National Electrical Code Article 300.3 covers wiring methods and general requirements. Section 300.3c specifically addresses conductors of different systems. This section states that conductors of different systems, whether alternating current, indirect current, or different voltage systems, shall not occupy the same enclosure, compartment, raceway, box, or cable. However, there are exceptions to this rule. The general rule prohibits mixing voltage systems in an enclosure, compartment, raceway, box, or cable. This means that, without an exception, a 480-volt circuit and a 120-volt circuit cannot be in the same gutter. Exception number 1 states that conductors of different systems may occupy the same enclosure, compartment, raceway, box, or cable if installed in a manner approved by the authority having jurisdiction. This provides flexibility, allowing the local electrical inspector to approve such installations based on specific circumstances and safety considerations. The authority having jurisdiction is the local electrical inspector or other responsible entity. Exception number 2 specifies that conductors of different systems may occupy the same enclosure, compartment, raceway, box, or cable where the conductors are under the sole control of one of the following: firstly, an electric utility, or secondly, a qualified person. This exception applies when the installation and maintenance are managed by an electric utility or a qualified individual. A qualified person possesses the necessary skills and knowledge related to the construction and operation of the electrical equipment and installations and has received safety training to recognize and avoid the hazards involved. Exception number 3 outlines further conditions under which conductors of different systems may occupy the same cable, box, or raceway. This exception has multiple subconditions. Subcondition states that the conductors are part of a listed control cable assembly. This means the conductors are within a cable assembly that has been tested and certified by a recognized testing laboratory. Subcondition B states that the conductors are part of a listed fire alarm system. This allows different voltage systems to be combined within a fire alarm system provided it is listed. Subcondition C states that the conductors are part of a listed signaling system, meaning that conductors within a listed signaling system are permitted to have different voltages. Subcondition D states that the conductors are part of a listed data processing system. This permits different voltage systems within a listed data processing system. To summarize, the general rule prohibits mixing 480 volts and 120 volt circuits in the same gutter, enclosure, compartment, raceway, box, or cable unless one of the exceptions applies. Firstly, if the authority having jurisdiction approves the installation. Secondly, if the conductors are under the sole control of an electric utility or a qualified person. Or thirdly, if the conductors are part of a listed control cable assembly, a listed fire alarm system, a listed signaling system, or a listed data processing system. Understanding these exceptions is crucial for ensuring compliance with the National Electrical Code while designing and installing electrical systems. It is always recommended to consult with a qualified electrical professional and the local authority having jurisdiction to ensure that all installations meet the code requirements and safety standards. When installing electrical systems, always prioritize safety. This includes using properly rated equipment, following manufacturer's instructions, and adhering to all applicable codes and regulations. Proper grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse and energizing the circuit. Bonding ensures that all metal parts of the electrical system are at the same potential, reducing the risk of electric shock. Before working on any electrical equipment, always de-energize the circuit. This can be done by turning off the circuit breaker or removing the fuse that supplies power to the circuit. Use a voltage tester to verify that the circuit is de-energized before touching any wires or components. Wear appropriate personal protective equipment, or PPE, when working on electrical systems. This may include safety glasses, rubber gloves, and insulated tools. Never work on electrical systems in wet or damp conditions. Water is a good conductor of electricity and can increase the risk of electric shock. If you are not comfortable working on electrical systems, hire a qualified electrician. Electrical work can be dangerous, and it is always best to leave it to the professionals. When working with electrical systems, it is important to understand the different types of circuits. A circuit is a closed loop that allows electricity to flow from a source to a load and back again. The source is the point where the electricity originates, such as a power plant or a battery. The load is the device that uses the electricity, such as a light bulb or a motor. There are two main types of circuits, namely series circuits and parallel circuits. In a series circuit, the components are connected in a single path. If one component fails, the entire circuit is broken. In a parallel circuit, the components are connected in multiple paths. If one component fails, the other components will continue to operate. The National Electrical Code, or NEC, is a set of standards for electrical installations in the United States. The NEC is updated every 3 years, and it is important to stay up to date on the latest requirements. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and bonding. It is a comprehensive document that provides guidance for safe and reliable electrical installations. Article 300.1 discusses the scope of Chapter 3 of the NEC, which covers wiring methods and materials. Article 300.2 addresses limitations of wiring methods, specifying where certain wiring methods are permitted or prohibited. Article 300.4 covers protection against physical damage, requiring that wiring be protected from damage by mechanical means. Article 300.5 specifies requirements for underground installations, including minimum burial depths and protection from corrosion. Article 300.7 addresses raceway systems exposed to different temperatures, requiring measures to prevent condensation and expansion. Article 300.11 covers securing and supporting wiring, ensuring that wiring is properly supported and protected from strain. Article 300.14 specifies the minimum length of free conductors at outlets and switches for making connections. Article 300.15 covers boxes, conduit bodies, and fittings where conductors are spliced or terminated, requiring that these be properly sized and installed. Article 300.17 addresses raceway fill, limiting the number of conductors that can be installed in a raceway. Article 300.19 covers supporting conductors in vertical raceways, requiring that conductors be supported to prevent excessive strain. In addition to the articles mentioned above, there are many other articles in Chapter 3 of the NEC that cover specific wiring methods and applications. These include articles on flexible cords and cables, armored cable, non-metallic sheathed cable, and rigid metal conduit. It is important to consult the NEC and other applicable codes and standards when designing and installing electrical systems. This will help ensure that the installation is safe, reliable, and compliant with all applicable requirements. When working with electrical systems, it is important to understand the different types of equipment that are used. This includes transformers, switchgear, panel boards, and motor control centers. Transformers are used to change the voltage of electricity. Switchgear is used to control and protect electrical circuits. Panel boards are used to distribute electricity to branch circuits. Motor control centers are used to control and protect electric motors. Each of these types of equipment has its own set of requirements for installation and maintenance. It is important to consult the manufacturer's instructions and the NEC when working with electrical equipment. It is also important to have a qualified electrician perform any electrical work. When selecting electrical equipment, it is important to consider the voltage, current, and power requirements of the application. The voltage is the electrical potential difference between 2 points. The current is the rate of flow of electrical charge. The power is the rate at which electrical energy is transferred. The equipment must be rated for the voltage, current, and power requirements of the application. It is also important to consider the environmental conditions in which the equipment will be used. The equipment must be suitable for the temperature, humidity, and other environmental factors. Proper maintenance is essential for ensuring the safe and reliable operation of electrical systems. Maintenance should include regular inspections, testing, and cleaning. Inspection should be performed to identify any signs of damage or wear. Testing should be performed to verify that the equipment is operating properly. Cleaning should be performed to remove any dirt or debris that could interfere with the operation of the equipment. It is important to keep accurate records of all maintenance activities. These records can be used to track the performance of the equipment and to identify any potential problems. Electrical safety is a critical concern for anyone working with or around electrical systems. Understanding the hazards associated with electricity and taking appropriate precautions can significantly reduce the risk of electrical shock, burns, and other injuries. Electricity has the potential to cause serious harm if not handled properly. The electrical shock occurs when a person comes into contact with an energized electrical circuit. The severity of the shock depends on several factors, including the voltage, current, and duration of the contact. Electrical burns can occur when electricity passes through the body, generating heat that damages tissues. Arc flash is a dangerous phenomenon that occurs when a short circuit creates a high-energy explosion of heat and light. Arc flash can cause severe burns, blindness, and even death. To prevent electrical injuries, it is essential to follow safe work practices. Always to energize circuits before working on them. Use insulated tools and equipment. Wear appropriate personal protective equipment, or PPE, such as rubber gloves and safety glasses. Never work on electrical systems in wet or damp conditions. Be aware of the location of overhead power lines and maintain a safe distance. If you are not qualified to perform electrical work, hire a licensed electrician. Grounding is a critical safety measure that provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse and energizing the circuit. Grounding helps to prevent electrical shock and fire hazards. Bonding is another important safety measure that ensures that all metal parts of the electrical system are at the same potential, reducing the risk of electric shock. Bonding helps to create a low impedance path for fault current to flow back to the source. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices automatically interrupt the flow of electricity when a fault condition occurs, preventing damage to equipment and reducing the risk of fire. Regular inspections and testing of electrical systems are essential for identifying potential hazards and ensuring that the systems are operating safely. Inspections should be performed by qualified personnel and should include a visual examination of wiring, equipment, and connections. Testing should be performed to verify the proper operation of grounding, bonding, and overcurrent protection devices. It is important to keep accurate records of all inspections and testing. Proper training is essential for anyone working with or around electrical systems. Training should cover the hazards associated with electricity, safe work practices, and the proper use of tools and equipment. Training should be provided by qualified instructors and should be updated regularly. Electrical safety is a shared responsibility. Everyone has a role to play in preventing electrical injuries. By following safe work practices, using appropriate equipment, and staying informed about electrical hazards, we can create a safer environment for ourselves and others. Always remember that electricity is a powerful force that must be treated with respect. Understanding the risks and taking appropriate precautions is essential for preventing electrical injuries and ensuring the safe operation of electrical systems. When installing electrical systems, it is important to follow the manufacturer's instructions and all applicable codes and standards. This will help ensure that the installation is safe, reliable, and compliant with all applicable requirements. Use only listed or labeled equipment. Listed or labeled equipment has been tested and certified by a recognized testing laboratory. This provides assurance that the equipment meets safety standards. Protect wiring from physical damage. Wiring should be protected from damage by mechanical means such as conduit or raceway. Avoid overloading circuits. Overloading a circuit can cause the circuit breaker to trip or the fuse to blow. This can be a nuisance and it can also be a fire hazard. Do not use extension cords as a substitute for permanent wiring. Extension cords are intended for temporary use only. They can be a fire hazard if used improperly. Keep electrical equipment clean and dry. Dirt and moisture can interfere with the operation of electrical equipment and can create a shock hazard. Have a qualified electrician perform any electrical work. Electrical work can be dangerous, and it is always best to leave it to the professionals. When troubleshooting electrical problems, it is important to follow a systematic approach. Firstly, identify the problem. Secondly, gather information. Thirdly, analyze the information. Fourthly, test the circuit. Fifthly, repair the circuit. Firstly, identifying the problem involves determining the symptoms and the extent of the problem. Secondly, gathering information involves reviewing the circuit diagrams and the equipment manuals. Thirdly, analyzing the information involves determining the possible causes of the problem. Fourthly, testing the circuit involves using a multimeter or other test equipment to verify the voltage, current, and resistance of the circuit. Fifthly, repairing the circuit involves replacing any faulty components and restoring the circuit to its proper operating condition. Always energize the circuit before working on it. Use insulated tools and equipment. Wear appropriate personal protective equipment. If you are not comfortable troubleshooting electrical problems, hire a qualified electrician. Working with electricity can be dangerous, and it is always best to err on the side of caution. It is important to have a thorough understanding of the National Electrical Code, particularly Article 300.3c and its exceptions, to ensure safe and compliant electrical installations, especially when dealing with mixed voltage systems and gutters or other enclosures. Consulting with qualified professionals and adhering to local regulations is crucial for maintaining electrical safety and preventing potential hazards.